So we're now going to take a look at estimating 2.5 to the power of 4. And we're going to explore it in a similar way to how we've looked at it before. Now, we would expect that 2.5 to the power of 4 will be somewhere between 2 to the 4, which is 2, 4, 8, 16, up to 3 to the 4, so somewhere between 2 to the 4 and 3 to the 4. 3 to the 4 is 81. So somewhere between 16 and 81. And we could use our estimating procedure that we've tried and tested up to this point. So if we do 81 take away 16, so 81 take away 16 is 65, and then if I divide that by 10, that's 6.5. So starting from 16, we would get 22.5. Then we would be at 23, 29, then 35.5, 36, 42, 48.5, 49, 55, then 61.5, then 62, 68, then 74.5, and then up to 81. Okay. Now, the actuals, I'm going to work those out in my calculator now. I'm going to round them because otherwise I'm not going to have enough space to put in all the decimal places. I'm going to round them to 2 decimal places, okay? Okay. And now I'm going to work out the difference between the estimates and the actual values. Okay, right. So, you can see that with our example here, that the difference between our estimates and the actual values are quite significant by this point. So the largest is actually, we're 9.44 out. So 48.5 against 39.06. So we can see again that all of our results are overestimates, as we saw when we were squaring or cubing. But this time we are a number of integers out. So in all likelihood, the best you're probably going to get at estimating is when you are closer to the tails. So 2.1 to the 4, 2.9 to the 4, you could probably have a reasonable guess at. But when you're at 2.5 to the 4, we're actually going to be near 10 away from the actual. So you've got to be able to take that into account. That's not the case. That's not necessarily the case between, if we were looking at 3.5 to the 4, if we are comparing your estimate to your actual there, the gap's going to even widen even more. So the most likely questions that you're going to get to the power of 4 will be close to the tails, because otherwise your values will be way off. And you know, that's not a fault of you. That's because our estimating procedure is kind of breaking down at this point, and it's not really working at much anymore the way that we would like it to be. So, I mean, we could take a punt and we might be in the kind of ballpark, but be aware that you're probably going to be a few integers out now, even more so now than we were when we were doing cubing terms or squaring terms.